Here we go, Ignite students. How we doing? We are wrapping up all the stuff going on out in space. We are wrapping up the astronomy part of this. Here we go. We've got Uranus and Neptune today together. They're twinsies. Here we go. Uranus, beautiful blue teal. Neptune, bright blue ball. Everything's great. All right. Here's the thing. These two were unknown. These two were absolutely unknown. Every single ancient civilization knew Mercury, Venus were on Earth, Mars, Jupiter, Saturn. Okay? So 5 in the sky, you're standing on one, the sun, the moon. Everybody knew that. They knew those 5 planets were different than all the stars. Uranus and Neptune were unknown. All right, in 1781, Herschel sees and discovers Uranus. He finds it in a telescope. Everything is good. It's awesome. Huge discovery. Because for 2,000 years, there were just 5 planets besides Earth. And now there's this one. We're adding it all in. So now what? Well, everything was good. Everything was good for a while. And then within 50 years, they're watching Uranus move around the sun, and it's not where it should be. Something's wrong. Something's wrong. And here it is. Here's the big one. Neptune was predicted. People kept measuring where it is and where it should be, where it is and where it should be, where it is and where it should be. And 2 independent mathematicians within 6 months of each other predicted where Neptune should be. That there's something that's holding this back and it's pulling it around and it's changing its orbit. So it's not just going around the sun with nothing else influencing it. They predicted Neptune, and it was found in 1846. 1846. Very, very recent, very incredible. Just that it was predicted was awesome. All right, here's the thing. You know something interesting? 1846, we found Neptune. All the way until 2010, it had made 1 lap around the sun. 1846 to spring of 2010, it made 1 lap. You would be 1 Neptunian year old. It's very, very far out there from our perspective. Okay, here we go. From our perspective, Neptune's year is 163.7 years. The Uranus year is 83 3/4 years long. Okay, the distance from the Earth to the Sun, Uranus is 20 times further than that, and Neptune is 30 times further than that. Okay, this is a great picture for scale for the gas giants and Earth, because Uranus and Neptune are not that far apart from each other, and they're not that much bigger than Earth. Okay, Uranus 14 times the mass of Earth, Neptune 17 times the mass of Earth. Okay, Venus and Mars smaller. Okay, half the size, 3/4 the size. These guys are bigger and close enough. Okay, so what do we know? Let's start with something really odd. Here we go. This. Uranus is bent over. Okay, make the joke. It's fine. It is tilted 98 degrees so that the North Pole that you see right here is not pointed up. It's pointed sideways, and it stays sideways. So if we start in 1986 here, the North Pole is getting 24 hours of sun. Not even 24 hours. Okay, we would say 24 hours relative to Earth. It rotates in the 10-hour range. It's rotating, but as it goes around the sun, North Pole starts to lose daylight until it's half and half. The sun's right on the edge. All right, so everybody around the equator gets a normal day, dark, day, dark, day, dark. It's going to stay warm year round. Then, as the North Pole moves over here, it's going to move around and around and around. All right. It's almost 42 years of darkness and then 42 years of light if you lived on the poles for an 83 and 3/4 year or trip around the sun. It's a weird thing to be tilted that far over. All right, 23.5 degrees is already odd for Alaska where you got 24-hour sun, right? This is much more extreme than all that. It's the only one that does it. Venus is upside down, so we can't say that it's unheard of, but it's definitely really unusual. Okay, what do we know about the planets? The atmosphere is a lot like Jupiter and Saturn. That the upper atmosphere is, let's say, 84% hydrogen, 14% helium, right? Very, very similar, trace amounts of methane, very, very similar to Jupiter and Saturn. The big difference is that there's no gaseous ammonia in Uranus and Neptune, but there is in Jupiter and Saturn. It's because they're further out. What's that got to do with anything? Because they are further out, they're colder. And because they're colder, the ammonia isn't a gas, it's more of a liquid phase. And it isn't observable. We can't measure it in the atmosphere because there's not a gas in the atmosphere that's ammonia. It's in the liquid phase. All right. Some other big things. There's not a lot of features on these guys. Okay. If you want to compare the cloud cover, right? The cloud cover that we've got going on the two of them, compared to Jupiter and Saturn, there are not these strong bands all over the place. There is the great dark spot here, okay? It's visible, not nearly as iconic as the great red spot. There are some cloud bands, but look, this is invisible. This is what it looks like. This down here is in infrared. This is really a heat map kind of thing, okay? Here we go. Magnetic field. This is a good one. It does include Earth. So remember, the terrestrial planets, the rocky guys, have weak magnetic fields. The gas giants have very, very strong magnetic fields. Okay? So this gray rectangle in any of these pictures, this gray rectangle represents, that says you could take a bar magnet and stick it inside the planet. And if the bar magnet was this strong, it would look just like this. The planet's magnetic field would act like this. So Earth has one, you can barely see the rectangle because Earth has a weak magnetic field, weak when compared to the outer planets. But you'll see that while Uranus and Neptune have stronger magnetic fields than Earth, they're much, much weaker than Jupiter and Saturn. Here's the other thing. All right, Earth, the magnetic field, the magnetic north, if you took a compass and just walked and walked and walked until it said you were at the North Pole, you would not be at the geographic North Pole and near Santa's house, okay? Not going to happen. The center of the North Pole is up in northeastern Canada right now, okay? Same thing. The axis of rotation for Jupiter and the magnetic North Pole are off by about 10 degrees. On Earth, it's 11 degrees. Saturn, they're lined up pretty good here. Uranus and Neptune, what happened? It's off-centered. It's leaned over. It's tilted all sorts of ways. 46 degrees for Neptune. I mean, Uranus is rotated at 98 degrees, so it's down that way. That's the North Pole. And this has got north up here. Here's the thing. Voyager 2 did all of this. Voyager 1, after it went to Saturn, Voyager 1 went up and out. So really one of the first and one of the few satellites to ever go by Uranus and Neptune's Voyager 2. All the information we have 1986 for Voyager 2, and then was it 3 years later? It was 89 for Neptune. So, yeah, no, 10 years later. Why did I say 82? Here we go. 79 and 89. Voyager 2 goes by these planets in 79 and 89. Sorry. So, magnetic field, here we go. Interior. Here are their cores, okay? They've split and put Uranus and Neptune in one figure because they are very, very similar. We're doing them in one chapter here, chapter unit discussion, because they're very similar. They are a gas giant. There is no solid surface. When that says rocky core, that does not mean solid rocks. That means that carbon and silicon and the elements that would make up rocks make up that same thing. Whether it's molten hot, maybe in the center of Earth, or it's iron, it just means it's not hydrogen and helium, really light things. Okay, the density of Uranus and Neptune is about 1,600, 1,700 kilograms per cubic meter. Water is 1,000 kilograms per cubic meter, so they both denser than water, denser than Saturn, but neither of them are dense as Earth, which is like 5,500, the whole Earth on average, if you take from the crust down through the core. 5,500 kilos per cubic meter. This other image just tries to show you in one picture what all four of them look like together, so you kind of see scale, that the relative size of the cores are different. This slush, that's where some of your ammonia is, liquid ammonia. It's not really that there's a ammonia ocean going on, it's just slush. Again, no solid surface in these planets. All right. The moons. Oh my goodness. The moons, first of all, these are the moons of Uranus here. You've got Earth's moon in frame for reference. You've got Oberon, Titania, Ariel, Umbriel, Miranda, Proteus. You got Puck somewhere not pictured. You've got all of these. And so some of you scholars may have noticed. So let's hover over this for a split second here. 1851. All right. We don't have good pictures of all these. Oberon, 1787. Puck, 1985. This, 1986. Here we go, 1787 by Herschel. Umbriel, 1851. All the planets and everything's kind of named after Roman and Greek gods, and all this continues. If you'll notice the literary moons, A Midsummer Night's Dream, King Oberon and his wife, and then Puck is a character in there. There are all sorts of, these are like literary names all of a sudden. Juliet's in there, all sorts of weird, Ophelia. So the pattern broke. They're not Roman gods or Greek gods anymore for Uranus. They are they're literary characters. Now, Neptune. Okay. Triton. Not Titan. Titan goes with Saturn. Triton, TR. Triton, oh, huge. Triton. Nitrogen ice. Triton was, is around Neptune. All sorts of other stuff is going on. 17 days after Neptune was discovered. So Neptune was predicted. Everybody goes and gets their telescope. I want to be the first one. I want to be the first one. Somebody finds it. 17 days later, they find the first moon. Okay, that's how soon Triton was found. Okay, the moons are cool. There is a ring system around both these guys here. Let's go to 15 here. These are images of some of the small moons. They've got odd features. All right. frozen lakes, unusual things. The first moons of Uranus were found by occlusion. Okay, what's going on is there's a distant star, and then when the rings go through and block some of the light from that distant star, you see the star get dimmer. You can do that to find moons, but you can also do it to find the rings. So the rings of Uranus were found by using stellar occlusion. Here we go. Here are the rings, fancy Greek letter names, alpha, beta, gamma, delta, etc. All right. Uranus also has rings. Here we go. Yep. Also very creative science names for them. You block out the brightness from the original star, you can find this. Okay. Here we go. Uranus and Neptune, teal, blue, very similar size, very similar composition, both very cold. Both have a couple moons, both have weird magnetic fields. They're very, very similar. All right, you know a couple differences between the two. Otherwise, get ready. We're going to wrap up. We're going to have some vocabulary practice, and you guys have a great day.